Good morning, everyone. Our topic today is Introduction to Cryptography, presented by Chimaju Oparocha. So, what is cryptography? Cryptography is the practice and study of techniques for secure communication that are related to various aspects in information security, such as data confidentiality, data integrity, authentication, and non-repudiation. Cryptography involves securing information with mathematical algorithms to transform information into a format that are unintelligible to unauthorized users. However, authorized users have the permission to transform it into a readable form. So let's say I'll give an example. Okay, let's say you want to send a message to your friend. The content of the message is meet me at my house at 3 p.m. Instead of sending the direct message to your friend, you use a code to hide the message, like you replace each letter of this message with a number. Then instead of sending the word meet me at my house at 3 p.m., you send the numbers. So you need to tell your friend that okay, this is what the number is, so that when your friend receives the number, the your friend will be able to transform that number into the actual message. So the message which contains the number you sent to your friend is what is called encryption. For your friend to transform this message, the numbers he received, to the letters, to the actual message, that's what is called decryption. So cryptography depends on two basic operations, which are encryption and decryption. Algorithms are the mathematical and logical processes used to encrypt and decrypt data. These algorithms are essential for securing information and communication, and they are the foundation of modern cryptographic system. Algorithm is like a recipe. It's a process you follow to get a particular result. Okay, let's say I want to make meat pie. I have to get flour, I have to get baking powder, I have to add sugar, I have to add every ingredient I need to achieve that. That's the way algorithm work. It's a pattern to which um something is made. So algorithm are mathematical and logical processes used to encrypt and decrypt data. So let's look at what encryption algorithm is. Cryptography uses encryption algorithm to convert plain text into ciphertext. Like I explained earlier, the meet me at my house at 3 p.m. is a plain text. Then the numbers which you use to send the numbers which you converted those texts to, sending it to your friend, let's assume that is a ciphertext. So encryption algorithm is a mathematical function or set of rules that takes plain text, that's an unencrypted data, as input and transforms it into a ciphertext, encrypted data. So the plain text is not encrypted, the ciphertext is encrypted. Encryption means like it's hidden. Using an encryption key, the algorithm is designed to ensure that the original plain text cannot be recovered without the corresponding decryption key or without performing an impractical amount of computing. An encryption algorithm would require a plain text and this and a key. These are the two things needed for an encryption exercise, which would then output the encrypted content into ciphertext. So the decryption algorithm would require you to have a ciphertext and a key to decrypt it. These are the two things required to perform an encryption. So what are the categories of encryption algorithm? There are two categories of encryption algorithms, which are symmetric encryption and asymmetric encryption. Symmetric encryption, also known as secret key encryption, uses the same key for both encryption and decryption. This means that the key must be shared between the parties involved in the communication. The security of symmetric encryption relies on the secrecy of the key. If the key is compromised, the encrypted data can be decrypted by anyone who knows the key. Okay, let's say I have I have an item I want to send to my friend. Like, okay, I send an email and I use a password to lock a particular information in that email. Okay, I'm sending that email to someone else, so that I'm sending that email to like a friend of mine, and I don't want anyone to have the access. I'm going to share that code with only the recipient, only the person I want him to receive the message. So in a situation where the code is shared with someone else, that means it's been intercepted. So the security of the asymmetric encryption relies on the secrecy of the key. If the key is compromised, the encrypted data can be decrypted by anyone. So it's only the recipient that will have that code inside in the email, that will have the code to decrypt that information in the email. So asymmetric encryption is relies on the secret key that is being given. I don't know if you understand me. I'm trying hard to explain this. Let me read it out again. Asymmetric key, also known as asymmetric encryption, also known as secret encryption. Secret key encryption uses the same key for both encryption and decryption. That means that the key must be shared between the parties involved in the communication. I'm sending a key. I'm sending an information that has a key. Then before the information gets to the person I'm sending it to, I also send the person the key to decrypt it. That is what symmetric encryption means. Advantages of symmetric encryption: it is faster and more efficient than asymmetric encryption because only one key is used. It is well suited for encrypting large amounts of data. What are the disadvantages? The, the key must be shared securely between the parties involved, which can be a challenge. If the key is compromised, the encryption is no longer secured. So, what is asymmetric encryption? Asymmetric encryption, also known as public key encryption, uses a pair of keys for encryption and decryption, a public key and a private key. The public key is made available to the receiver, while the private key is kept secret and is used to decrypt the data. The security of asymmetric encryption relies on the secrecy of the private key. What are the advantages of asymmetric encryption? It does not require secure key exchange because the public key can be shared freely. It can be used to create digital signatures, which can be used to verify the authenticity and integrity of the data. Okay, I carried out a practical on the second video, so you see how we used the public key and the private key to create a digital signature. So, what are the disadvantages of asymmetric encryption? It is slower and less efficient than symmetric encryption because it uses two keys, it uses two key pairs. It is not suited for encrypting large amounts of data because it's slower. So, what are the primary goals of cryptography? The primary goals of cryptography are to ensure the confidentiality, integrity, and availability of data. These goals are often referred to as the CIA triad of information, information security. So, confidentiality means ensuring that data is kept secret and can only be accessed by authorized parties. Encryption is the primary technique used to achieve confidentiality. When we use cryptography to protect confidentiality of an information, we consider three things. Data at rest, that is when the information is still on your hard drive or your storage device. Data in transit, that's data transmitted over a network connection between two systems. The third one is data in use. That is when the data is being actively used in application. So confidentiality is when, like, you send a message to someone and you no unauthorized user have access to that information. The next primary goal of cryptography is integrity. Integrity is ensuring that data has not been altered or tampered with. This is self explanatory. This is achieved by using hash functions or message authentication codes, that's marks, to create a checksum or digital signature that can be used to verify the integrity of the data. The next goal of cryptography is availability. Availability is ensuring that the data can be accessed and used by the authorized parties when needed. This involves that the data is not lost or destroyed and that the encryption and decryption process do not take too long. Another one is obfuscation. Sometimes we want to make data intelligible to anyone, including ourselves. Obfuscation is a method of making something harder to see or understand. Example, like say you save your NIN number in a format that is not easily understood, so that when someone gets access to it, it will not easily be understood. That is a NIN that okay, they will not easily understand that is a NIN number. This is another purpose of cryptography. Like changing, let's say your NIN number is 12345, you can change it to ABCDE. So another goal of cryptography is non-repudiation. Non-repudiation prevents individuals from denying that their involvement in a communication or transaction. Digital signature plays a crucial role in non-repudiation. Digital signatures are used to achieve non-repudiation. Let's say I sign a document like digitally and I send it to someone else. The digital signatures would say that I'm the one that signed it and I cannot deny it in case of any emergency or any situation. I cannot deny it that I'm the one that signed it. So the information is there. So what is a digital signature? A digital signature is a mathematical technique used to validate the authenticity and integrity of a digital document, message, or software. It is the digital equivalent of a handwritten signature or stamp seal, but it offers far more inherent security. A digital signature is intended to solve the problem of tampering and impersonation in digital communication. Example of a digital signature is the email signature that we often add at the end of the email and check the terms and conditions box in the software installation process. Remember when you're trying to download something over your phone, like they would send okay, there will be like a checkbox on the end of the page. It will tell you accept our terms and conditions. I don't know if you've taken note of that. That's an example of digital signature. During our class, we'll carry out this class exercise of how to change normal words. We'll be using this website to change a particular word to a cipher text. So, what is a code? A code is a system of substituting word, phrases, or sentence for other words phrases, or sentence according to a code book or list. This method was commonly used in historical cryptography, especially before the invention of modern computers. Codes are a form of direct substitution where the meaning of the original message is preserved but presented by different words or symbol. Taking an example, a code might replace meet at the park with gather at the green in a code book. I think this is self-explanatory. The green, let's say we're assuming the green is the grass, then gather, like let's meet at the park. So like when you read this gather at at the green, you could easily understand this. What it means is let's meet at the park. So a cipher is a method of transforming the content of a message to hide its meaning. It uses an algorithm and key to perform a complex transformation on the plain text, resulting in ciphertext. Ciphers can be symmetric, using the same key for encryption and decryption, or asymmetric, using a pair of keys, a public and a private key, for decryption. An example of a cipher is a cipher might replace each letter of an alphabet with another letter or symbol according to a specific rule, like the Caesar cipher, which shifts each letter by a fixed number of position. So, cryptographic maths. Cryptographic maths is the foundation of modern cryptography, which is the practice of securing information by converting it into a form that cannot be easily understood by unauthorized parties. Cryptographic algorithms and protocol rely on complex mathematical concepts and functions to ensure data confidentiality, integrity, and authenticity. Basic terms that support cryptography is: 1. Exclusive XOR operation, confusion, and diffusion. So the exclusive OR operation, let me go down to explain this in easy terms. So let me explain the XOR explained in details. Okay, the exclusive XOR is, let's start with two numbers. Let's say you have two numbers, 5 in one box and 3 in another box. Let's do the math. You take the first 5 and the second number 3 and do a special kind of math called the XOR. You do this by looking at the first digit of each number and seeing if it's the same or different. If it's the same, you write an O. If it's different, you write an A. When you watch the video on digital signature, you would understand where this comes in. The practical of creating a digital signature with OpenSSL, you understand where this comes in, where you compare the hashes from the sender and the during the encryption process and decryption process. That's where you understand where the XOR comes in. So you repeat for each digit. You do this for each digit of the numbers. So for 5 and 3, you get the first digit of 5 is 5 and the first digit of 3 is 3. Since they are different, you write 1. The second digit of 5 is 0 and the second digit of 3 is 0. Since they are the same, you write a 0. The third digit, just read it up. We're going to provide the slide. So so the next topic we're going to consider in cryptographic maths is confusion. In cryptography, confusion refers to the property of a cryptographic system that makes it difficult to determine the relationship between the plain text and the ciphertext. Confusion is one of the two principles that are used to achieve security in a cryptographic system. The other being diffusion. Confusion is typically achieved by using complex nonlinear transformations in the encryption process. These transformations should be designed in such a way that it is difficult for an attacker to predict the effect of a given plaintext bit on the corresponding ciphertext bit. This makes it harder for an attacker to mount cryptanalysis attack such as linear cryptanalysis or differential cryptanalysis, which exploits pattern in the encryption process. Next one is diffusion. Diffusion refers to the property of a cryptographic system that makes it difficult to determine the relationship between a small change in the plaintext and the resulting change in the ciphertext. Confusion is one of the two principles that are used to achieve security in a cryptographic system, the other being confusion, which we talked about earlier. How to choose the right encryption algorithm for your organization. Choosing the right encryption algorithm for your organization depends on several factors, including the type of data you need to protect. Every organization is unique, and they need to personalize choosing the kind of encryption they want to use. So here are some steps to help you choose the right encryption algorithm. One is understand your data. You need to understand the kind of data you use in your establishment. That is one of the points. You assess the threat model. Consider the potential threats to your data, including the type of attacks you are likely to face. This will help you choose an algorithm that is resistant to those attacks. Evaluate performance. Determine the performance requirement of your system. Some equation algorithms are more computationally intensive than others, which can affect system performance. Number four is review regulatory requirements. Five is consider key management. Six is evaluate algorithm strength. Seven is look for industry standards. So what are the some common encryption algorithm? Okay, you see how these encryption algorithms are used when you watch the practical videos. So advanced encryption standard, that's the AES, is a symmetric block cipher that is widely used and considered very secured. It supports key lengths of 128 bits, 192 and 256 bits, and is suitable for protecting sensitive data. The RSA is a asymmetric encryption model that is widely used for secure key exchange and digital signature. We used this encryption algorithm during our practical. It is slower than symmetric algorithms, but is necessary for many cryptographic applications. We have the secure hash. This kind of algorithm is used to perform hash functions. It's a cryptographic hash function that is used to protect the integrity of data. It is not an encryption algorithm, but is often used in conjunction with encryption algorithm. So they have the transfer layer security. TLS is a protocol that is used to secure communications over a network. It uses encryption algorithms to protect the confidentiality and integrity of data in transit. What is the perfect encryption algorithm? There is no such thing as a perfect encryption algorithm, as the security of an encryption algorithm can change over time as new attacks are discovered. However, there are several encryption algorithms that are widely considered to be very secure and suitable for protecting sensitive data. Here are some characteristics of strong encryption algorithm. We have the strength. The encryption should be strong enough to resist all known attacks. It should be computationally invisible to break the algorithm by trying all possible keys, which is known as brute force attack. Confidentiality. The algorithm should provide confidentiality by ensuring that only authorized parties can access the encrypted data. Integrity. The algorithm should provide integrity by ensuring that the encrypted data has not been tampered with. Of availability, key management, implementation, standard compliance. Another topic we'll look at is OTP. I'm sure we all know what OTP is. If you use a bank account, you should know what an OTP is. An OTP is a form of security. OTP is a password that is valid for only one login section or transaction. It is a temporary code that is used to authenticate a user's identity and is typically generated by a hardware token, software application, or SMS message. Here is how an OTP works. User registration. The user registered with the service and is issued a token or application that generates OTP. Like in Nigerian banks today, we have hardware token and software token. Um, so when you open a bank account, you need a token to finalize every payment and transaction. The bank uses this format to make sure the transaction was authorized. So login request, when the user wants to log into their account, they enter their username and password as usual. The service generates a one-time password and sends it to the user via SMS, email, or mobile application. The user enters the OTP into the login page. The service verifies the OTP against the one is sent to the user. If the OTP is valid, the user is authenticated and granted access to their account. Once the OTP is used or a certain amount of time has passed, it becomes invalid and cannot be used again. That means it's a one-time thing. OTPs are used to provide an additional layer of security to traditional username and password authentication. They are designed to prevent unauthorized access to an account, even if the username and password have been compromised. OTPs are commonly used for online banking, mobile banking, and other sensitive online transactions. They are used for two factors authentication, which is a security process in which the user provides two different authentication factors to verify their identity. So TFA, there's a Google authentication system. Like some companies would require you to use that if you want to finalize a transaction or authorize yourself into a particular app. You have to use the Google authentication. The Google authentication sends you, like when you open the Google authentication system, you see a number. With that number, you can use it to complete your transaction. The cryptographic life cycle. The cryptographic life cycle is a set of steps that are used to manage the use of cryptographic algorithms and key. The goal of the cryptographic life cycle is to ensure that cryptographic algorithms and keys are used in a secure and effective manner. So I'll explain, you read up this, I'll explain what a cryptographic life cycle is for easy understanding. So imagine you're sending a secret message to your friend. Here's how the cryptographic life cycle works. You create a plan for keeping secret. That's the cryptographic policy development. Just like you and your friend need to agree on a secret code or handshake, organization creates rules for how they will use encryption. They decide which strong codes, that's the cryptographic algorithm, to use and how to manage the keys that unlock these codes. So the key generation is you make secret codes, that's the key. Just like you and your friend might use a random string of words or numbers as your secret code. So you make secret codes just like you and your friend might use a random string of words or numbers as your secret code. Cryptographers use special machines to create random keys. These keys are super long and random, making them hard to guess. That is what key generation is. So now you now share the code safely. That's key distribution. Now you have to get the secret code to your friend without anyone else finding out. This is like sending the key to an encrypted message in a way that only the intended recipient can access it. That's the key distribution. So the next cryptographic life cycle is the key storage. As you keep the secret code safe. Once you have your secret codes, you need to save it, keep it safe. This means storing it in a place where no one else can find it. Use the secret codes to send message. That's the key usage. When you want to send a secret message, you use the code to turn the message into something unreadable. That's called encryption. Your friend uses the same code to turn the message back into something readable. That's the decrypt it. So you tell people when the secret codes are no longer safe. You stay sorry, key revocation. If so, that's the other stage of the cryptographic life cycle. If someone finds out your secret code, you need to let everyone know it's no longer safe to use it. This is like telling your friend to throw away the old secret code and come up with a new one. As when the key has been compromised, it's automatically revoked. So the next stage is key destruction. Once you are done with using a secret code, you need to destroy it so no one can ever use it again. This is like burning or shredding the paper with the secret code on it. So check in regularly to make sure everything is working. That's the last stage, audit and review. That's the last stage of the cryptographic life cycle. You and your friend might check in from time to time to make sure that no one has discovered your secret code. Organizations do the same with their encryption, making sure their codes and keys are still going safe. So, what is a digital certificate? We did the practical as well. You can see, okay, but what we created was a self-signed digital certificate. The one we created is mostly used by website developers, so it doesn't need like a certificate authority. So what is a digital certificate? A digital certificate is like a special ID card for websites. It shows the website is who they say they are and that the information you're sharing with them is safe and secure. How does it work? You get a digital certificate just like a person gets a government issued ID card. A website gets a digital certificate from a company called the certificate authority. You verify the ID. The certificate authority checks to make sure that the website is really who they say they are. They do this by looking at the website information and maybe even calling the company to make sure everything is correct. They issue the certificate. Once the certificate is once the certificate authority is sure the website is real, they issue a digital certificate. This certificate has information about the website like its name and where it's located, and it's all locked up with a special code called encryption. So you show the certificate. When you visit the website, your computer checks the digital certificate to make sure that the website is real. If the certificate is good, your computer lets you visit the website. If the certificate is bad or missing, your computer might warn you that the site might be fake. So these are the steps, these are the practical we've done. These are the steps to follow to do the practical. So creating a digital signature, the sender creates a confidential message using a hashing algorithm that's either SHA-256 or SHA-512, etc. Then also creates a private key and signs it. The sender or signer sends the message, the signature, and his public key to the recipient. So for the on the receiver's end, the receiver uses the public key that was sent to him, creates a hash or value. Then this is the confidential message. The receiver needs to use, if the sender used SHA-256, the receiver has to use SHA-256 to decrypt the message. If the receiver used SHA-512, this the se- sorry, if the sender uses SHA-512, the sender has to use SHA-512 to decrypt the message. So once the receiver gets the message, he now compares the hashes and makes sure it's the same using a digest. Okay, I did the practical at the end of the video. That's the second video. Try and make sure you watch it so that you know how to create your own digital certificate and also a digital signature. Thank you so much, everyone. That's the end of the class. Bye.